Good morning everyone. Today we will be studying about topics such as symbols, formulae and atomicity. The first topic that we will be coming across is symbols. As we know that there are only 118 elements and millions of compounds. The elements and compound react with each other in innumerable way. Writing their full names of the element and compounds and describing their reactions is very inconvenient. It is more convenient to use abbreviation or symbols. So we use symbols to represent elements. A compound is represented by a formula which contains symbols of that element present in a molecule of that compound. Early scientists and alchemists used picture symbols to represent elements. Later, Dalton improved over these symbols. He used the symbols such as this for hydrogen, this for carbon, this for oxygen, silver, gold, iron, and some of the symbols that are used by the alchemists and Daltons. But as the number of known elements and compound increased, this method became very tedious. Now, the present system uses letters of the English alphabet to represent element. It was first suggested by Berzelius. The system is as follows. First, some elements are represented by using the first letter in capital form of the name of that element. For example, C for carbon, N for nitrogen, and O for oxygen. Second, the names of some elements have the same initial letters. For example, Ca for carbon, Ca for calcium, and Co for cobalt. In such cases, the first letter is taken in capital together with the letter in a small form for its name. For example, Ca for calcium, Co for cobalt, and Ba for barium, and Br for bromine. The symbols of some elements are derived from their Latin names. For example, Latin name of copper is cuprum and its symbol is Cu. Latin name for potassium is calcium and its symbol is K. Latin name for iron is ferrum and its symbol is Fe. Then Latin name for sodium is natrium and its symbol is Na. Now let us learn about formula. We know that molecule of water contain two atoms of hydrogen and one atoms of oxygen. Therefore, the formula of water should contain the symbols of hydrogen and oxygen. It should also show the number of atoms of each element in a molecule. So we write the formula of water as H2O1 or simply H2O. Now let us learn about molecular formula of an element. We know that atoms of sub-element cannot exist independently in nature. They form molecules containing two or more atoms. Thus, H2 represents a molecule of hydrogen, O2 represents a molecule of oxygen, and Cl2 represents a molecule of chlorine, and N2 represents a molecule of nitrogen. Now, let us learn about molecular formula of compound. Each compound is represented by a chemical formula with the help of a symbol and a valency of different atom present in it. Similarly, the formula represents the molecule of a compound, therefore it is more commonly known as its molecular formula. Molecular formula. It is a molecular formula of a compound is the symbolic representation of its molecule. It shows the number of atoms of each element present in it. These atoms combine in whole number to form the molecule. For example, the molecule of sulfur dioxide gas is represented as SO2. It indicates that one molecule of SO2 is formed by one atoms of element sulfur and two atoms of element oxygen. Now let us learn about how to write the chemical formula of a compound. To write the chemical formula of a compound, the following information should be available. First, symbols of element that constitute the compound. Second, valencies of the element. Third, the number of each kind of atoms present, that is the ratio in which atoms are present in a molecule. And fourth, the mass of one molecule of that compound that can be calculated. Now, let us learn about the method for writing the formula of a chemical compound. First, magnesium oxide. The first step we will be writing their symbols and valencies. So symbol of magnesium is Mg and that of oxide is O. Say a valency of magnesium is 2 and that of oxide is 2. Now reduce the valency to their lowest ratio. Since it is divisible, so we will reduce it. Then after reducing, interchanging their valencies, this valency will come at the base of this oxygen and this one will come at the base of this Mg. So M1O1. Now ignore the base as it is 1, so the formula will become MgO. Take another example, that is calcium nitride. First we will write the symbols and valencies. Calcium symbol is Ca and that of nitride is N. Valency of calcium is 2 and that of nitride is 3. Now Ca valency 2 and N valency is 3. Since it can't be reduced to its lowest term, so it will not be reduced. So this 2 will come at the base of N and this 3 will come at the base of Ca. So Ca3N2. So the formula will be Ca3N2. Now let us learn about atomicity. The number of atoms of an element that join together to form a molecule of that element is known as the atomicity of that molecule. Depending upon the atomicity, the molecule of element can be divided into four categories. First is monoatomic molecule, second is diatomic molecule, third is triatomic molecule, and fourth is polyatomic molecule. But in this chapter, we will be studying about the two categories, that is monoatomic molecule and diatomic molecule. Monoatomic molecule, they contain only one atoms of metals and metalloids do not combine with their own type of atoms, so their atoms are regarded as their molecules. Similarly, atoms of inert gases exist freely under all conditions. All these elements are said to have monoatomic molecules. For example, Na, sodium, Zn, zinc, Mg, magnesium, etc. And noble gases like He, helium, Ne, neon, Ar, argon, and etc. Now, second is diatomic molecule. Diatomic molecule, they contain two atoms of the same type. For example, H2, O2, N2, Cl2, etc. That's all for today. We will be covering rest of the topics in the next video. Thank you.